Alright, hi everyone. Tonight we are going to look at graphing quadratic functions by hand. And we've kind of started this a little bit by looking at when we graph the tables of values, the x and the y, the input and the output. But today we're going to graph the quadratics using the vertex and using the y-intercept. So we're going to take a look at that. So let's go ahead and get started. Okay, first we're going to review just some vocabulary that we've gone through on this unit so far. And the first one is what this is called, this right here. And this is called a quadratic function. And what makes it quadratic is the fact that this polynomial, the highest degree is a 2. That makes it a quadratic function. And so quadratic functions can sometimes just have the first term, like y equals ax squared, like y equals 5x squared. That's a quadratic because the 2 is the highest degree. Then we can include the constant. We did this in class the other day. We have negative 2x squared plus 7 is a quadratic because of the 2. And then we have all three terms, the x squared, the x, and the constant right here. So all of these are quadratic functions because the highest degree of any term in that equation is 2. We know that the graph of these functions is called a parabola. And the parabola makes a curved shape, and we can have a high point on that parabola, like one that goes downward, or a low point on that parabola, and we call this the vertex. That's the highest or lowest point depending on if it's opening upward or opening downward. So some key features of this lovely formula right here. If the coefficient of x squared is bigger than 1, and that means that a is positive, then the parabola will open upward. And the vertex will be a minimum because it's going to have a low point. If the coefficient of a, the coefficient of x squared, if this a right here is negative, which means it's less than 0, then our parabola is going to open downward. And in that case, it's going to have a high point or a high vertex, and we call that a maximum. So the negative will give us a parabola that opens this way. A positive a in front of x squared will give us a parabola that opens upward or that way. So we talked about this a little bit in class on Wednesday. What does other than telling us the direction of the opening, what does the coefficient of x squared tell us? And so we looked at what made the parabola wider or narrower. So if the coefficient of x squared was less than 1, meaning that it's a decimal, and we're talking about the absolute value, the parabola will be wider. That makes the parabola wider than this parent function, or the function y equals x squared. So a smaller coefficient gives us a wider parabola. The opposite of that is true as well. When the coefficient of x squared is bigger than 1, the absolute value is bigger than 1, that's what's going to make our parabola narrow. So it'll be narrower than x squared. And if the coefficient is the same as 1, or is 1, that means it's going to be the same width. So when we talk about describing a parabola, we look at its width, we look at its vertex, its axis of symmetry, its x-intercepts, its y-intercept, to describe or to compare one or more parabolas. Okay, so let's go back and talk about the vertex for just a little bit. The vertex, we already said, is the highest or lowest point on the parabola, and it is also on the axis of symmetry. So we talked about the axis of symmetry has to go through the vertex. So we have a formula for finding the vertex. Well, actually a formula for finding the axis of symmetry. This formula here will tell us what the axis of symmetry is. So we use the coefficient of x squared, we use the coefficient of x, and we plug them in this formula, and this will give us the axis of symmetry, and we can use this to find the coordinates of the vertex without graphing. And so what happens, we'll get the axis of symmetry, which is always the x coordinate of the vertex, and we can use x to find y. So without graphing the quadratic function, we are going to complete the information below. So let's look at this function right here. Y equals negative 3x squared minus 7x plus 1. So we are going to look at the coefficient of x squared. That is positive, so that tells us that the parabola is going to open upward. And that also tells us, because it's opening upward, that the parabola is going to have a minimum, or the vertex is going to be at a low point. Because the 3 is bigger than 1, this is going to give us a narrower graph. So wider or narrower, I can't even say narrower, wider or narrower than x squared, it will be narrower. And why will it be narrower? Because 3 is less than 1. If it's, no it's not, 3 is greater than 1. Because 3 is greater than 1. Sorry about that. Because 3 is greater than 1. So bigger than 1 will give us a narrower parabola. Less than 1 will give us, or the absolute value will give us, a wider parabola. Okay, so what can we use all this information for to graph without using a calculator? So first we're going to look at this function, f of x is negative x squared plus 2x plus 3. A is the coefficient of x squared. So what is the coefficient of x squared? It's not there, so we're going to make it a negative 1. B is the coefficient of x, and then c is always our constant. So we can use this formula right here to do a couple things. We can use this to find, this will give us the axis of symmetry, which is also the x value of the vertex, because the axis of symmetry has to pass through the vertex. So all we need to do is use this formula, take out b, substitute 2 in for b, and it's negative 2 because this is negative right here. We're going to substitute in negative 1 for a, and then we're going to solve, and we get negative 2 over negative 2, and that gives us a positive 1. So the axis of symmetry is x equals 1. This is also the x value of the vertex, so we have to find the y value of the vertex. And to do that, we're going to substitute x equals 1 into our equation, y equals negative x squared plus 2x plus 3. So I'm going to take out x, and I'm going to plug in 1. So negative 1 squared plus 2 times 1 plus 3 is going to give us negative 1 plus 2 plus 3. Combine those, and we get y equals 4. So our vertex, which is going to be a maximum, is going to be at the point, there's our axis of symmetry, it's 1, we got that from right here. And our y value is 4, we got that from right here. So our vertex is going to be at the point 1, 4, and the point 1, 4 is right here. So that's one point that we have, and we know it's the highest point. So I'm going to go ahead and fill in the table over here. Our vertex is the point 1, 4. Needs to be written as an ordered pair. The axis of symmetry is always the x value of the vertex. We found that over here, and that's at x equals 1. The coefficient of x squared is negative, so we know that our vertex is going to be a maximum. And why? Because the coefficient of x squared is negative. So if it's a maximum, that means that the direction of our opening is downward. If we compare this to the graph of y equals x squared, they would have the same width. So in order to graph this, we need a few other points. So we can use the y-intercept, and if we look at our equation over here, the y-intercept we talked about in class on Wednesday, the y-intercept is the constant. So the y-intercept is the point 0, 3. So we can graph the point 0, 3. And now we have 2 points. So how do we find more points? So looking at this parabola, we know that the vertex is the turning point. And we know that this is the line of symmetry. The line of symmetry, the axis of symmetry is going to go through this point. So all our points need to be symmetrical. So I'm going to take a point, another point to the left of the vertex and another point to the right of the vertex, another x value, and I'm just going to plug it in the equation. So I'm going to pick x equals 2. And if x equals 2, we have to find y, and we're going to plug it in the equation, negative x squared plus 2x plus 3. And when I plug negative 2 in there, or positive 2 in there, what I end up getting is y equals 3. So 2 will give me a point right there at y equals 3. So now I want to pick just one more point. I will pick a point, again, we know that this is the y-intercept. I'm going to pick the point negative 1. So if x equals negative 1, I'm going to plug negative 1 in this equation. So it's negative 1 squared plus 2 times negative 1 plus 3. And when I work that out, I get 0. So there's an x-intercept right there at 1, 0. And if I look at the shape of the graph, I want this to be symmetrical. Chances are my other x-intercept is going to be right here, just by using the fact that the axis of symmetry divides this parabola into 2 equal parts, and the axis of symmetry is the halfway point between the two x-intercepts. So if we look at x equals 1, it's the halfway point between negative 1 and positive 3. So 2 additional points that I have for graphing this. I had the point 2, 3, which is this one right here. And I also had the point negative 1, 0, which is this one right here. And just by using the shape of the graph, a third point can be 3, 0, which is this point right here. So without making a table, we can use the axis of symmetry, the vertex, the y-intercept to graph our quadratic function. Okay, now it's your turn. So compare y equals x squared and y equals 1/2 x squared. How would the width of the parabolas change from the first quadratic to the next? So is this parabola y equals 1/2 x squared going to be wider than y equals x squared or narrower than y equals x squared? So using number 2, using the quadratic y equals negative 2x squared plus x plus 3, what direction would the parabola open? So your answers are either going to be upward or downward. And what determines that is this number right here. So refer to your notes from tonight, refer to your notes from the night before last, and from the classwork on Wednesday. Be sure to enter your answers on the Google form. Thanks. Have a great night.